Notice that if I move the cosine up, I end up with secant squared theta. If I move the cotangent up, I end up with tangent squared theta. You see that? So if you were to take what we've talked about this before, if you take the denominator and move it to the numerator, you write the reciprocal function. So when I move the cosine to the numerator, it becomes a secant, and I already have a secant there, so I end up with secant squared. When I move the cotangent to the numerator, it becomes tangent, and I already had a tangent there, so I get tangent squared. And what is secant squared minus tangent squared? 1. Okay. And so we already see how to move from 1 to this. And so then my steps, so from 1, right after 1, I'm going to put secant squared theta minus tangent squared theta. So that would be my first step from 1, because those are equal by the Pythagorean identity. And then I know I need to somehow split it up into these fractions. So maybe a good next step is to split the secant up to secant times secant, tangent to tangent times tangent. And then I'm going to take one of each of these, the secant and the tangent, and move it to the denominator. And so I end up with secant over cosine minus tangent over cotangent. And so I started with the left side, and I've ended up with something that's equal to the right side. Okay. And again, what I did in blue here was I started by looking at the right side to get some hints to what I should do if I'm stuck. We'll practice this a few times, but this is kind of the game of proving that you're going to work at getting good at. So number 2, let's try this one. Cosecant squared theta. We're going to start with that, and we want to end up with secant squared theta over secant squared theta minus 1. I'm going to give you a couple minute head start here, and then we'll work on it together. Again, we want to start with the left, make it equal to the right. On these, I'm purposely making the left side more simpler and the right side more complex, because not everything you have is going to be like this, but these are the ones you're going to have trouble with. And the ones you're going to have trouble with are the ones I want to work through with you, so you have something to work off of when you have to do it your own, okay? So because the right side is more complex, it is easier to take a look at that if you need a hint to try to figure out what do I do first. So I'm going to start by looking at the right-hand side. And on that case, I notice that the denominator is equal to what? Tangent squared. I could also rewrite this as secant squared times cotangent squared if I wanted to get rid of the fraction. There's multiple ways to do this. If I change it to sine and cosine, this is 1 over cosine squared, and cosine squared over sine squared. And then that's going to end up being 1 over sine squared, which is my cosecant squared. So I'm starting with cosecant squared, and so I need to move in this direction, right? And so as I write my proof up, I'm going to start with cosecant. The next thing I'm going to do is change to 1 over sine squared, and then I'm going to try to create what I have here. Okay, so I have some direction now, and now I'm going to write the proof. So after cosecant squared, write 1 over sine squared theta. I need to introduce cosine somehow. And so then the next step is going to be 1 over sine squared times what? Cosine over cosine. And I want cosine squared, so cosine squared over cosine squared. Because all I'm doing by multiplying by cosine squared over cosine squared is multiplying by 1. And so the value stays the same. Okay. So now I'm going to switch the way this looks, right? I'm going to shift this cosine over this direction so that I can create a cotangent. So I get cosine squared over sine squared times 1 over cosine squared. And what's cosine squared over sine squared? That's my cotangent. And 1 over cosine is secant. Okay. And so I've now made it to that step. Okay, so now I want to go from secant cotangent to secant over tangent. So I write secant squared theta over tangent squared theta. And now last step, change the tangent squared to secant squared minus 1. Sometimes it could get a little jumbled in your work, and it's hard to see what's the next line that you're doing. So putting equal signs in front of each case will signify to me, okay, where's the next step, where's the next step, and so on, and help me follow your work. So do that, or you can use arrows in between, something to separate one step from another. Question on that one? And again, in showing your work, you do not need the part that I'm erasing. That was kind of scratch work to help us figure out what our first and second and third steps were. Let's try one more. This time I'll give you even more time, see if you can get to the answer. So show that sine squared is equal to secant times sine over tangent plus cotangent. Okay, so on this one, again, I made the right side a lot more complicated than the left side, just to practice this working on the right side to help us with the left side technique. So I started by changing everything in terms of sine and cosine. So it's a technique that does help sometimes. In this case, it can be helpful to us. So if I do that, then I'm going to now focus on the denominator. You get a common denominator, so I need to multiply by sine over sine on the left side, and cosine over cosine on the right side. And so I end up with sine over cosine all over sine squared plus cosine squared over sine cosine. And sine squared plus cosine squared is 1, so that's going to be helpful to us. So now I have sine theta over cosine theta all over 1 over sine theta cosine theta. So when you have a fraction over a fraction, you can divide fractions by, we've done this before, right? Multiplying by the reciprocal of the denominator. So that's going to be sine theta over cosine theta times sine theta cosine theta over 1. And now we can reduce this and we end up with sine squared. And that's what we're starting with, right? The sine squared. So now we have we know we can get there. We just need to work backwards. So I'm starting with sine squared. I need to create this next one. So from sine squared, I'm going to write sine squared theta, and then what? Multiply by cosine over cosine, which is just 1. So that's my first step. And I still want to change it to look like this. And so I can rearrange my factors here. And I can rewrite it now as sine over cosine times sine theta cosine theta over 1. So now I've completed and I've made that that second piece look just like what I have now. And now I want to go from here to here. So I'm going to change this into a division problem. Sine over cosine over 1 over sine theta cosine theta. I've made that one work. Now I need to go from here to here. So I'm going to change the 1 to sine squared plus cosine squared. And now I've created that piece. And just keep working my way backwards. I'm almost there. Now I'm going this direction. So I need to split up the bottom into 2 fractions. And if you want, we can move that cosine back up because eventually we're going to just have it that way. So cosine, when I move that up to the numerator with sine, that becomes a secant sine. So that's the top part of this fraction. And I'm splitting these fractions up. I'm going to write sine squared over sine cosine plus cosine squared over sine cosine. When you split up a fraction, the denominator needs to stay the same, and you're just splitting the numerator up. Where would I go next from this? What's that? So I need to reduce these fractions, right? So I need to reduce the sine here and reduce the cosine here. Secant theta sine theta over sine over cosine plus cosine over sine. And then the last step, change sine over cosine to tangent and cosine over sine to cotangent, and we made it. So what I'm giving you are the more extreme cases. Most of them are not this long and difficult, but some of them will be. And so I need to give you some practice with each other before you try this on your own, okay? So that's why I'm doing this. I'm going to stop there, and I want you guys, I want to spend the rest of the period just you trying these proofs. If you get stuck, I want you to be able to ask each other, ask me. Always start with the left side, make that left side turn into the right side. That's the goal.